Well, the little Lorch is temporarily bolted down. It needs some work doing on the tailstock. Something's going on there, yeah. So what we're going to be doing is going to make some belting to go from the motor to the headstock. And what we have here is some 5mm polyurethane belt. Of course, if you're doing this properly, what you do is you make up a little jig to do them with, but I've never been known to do anything properly. Not many things properly anyway. So, second belt for that end. And that's good, that's how we're going to drive the spindle. But how are we going to drive the counter shaft? Well, on the back of that counter shaft there's a little engine, a little motor. It's a 3-phase motor. I don't have 3-phase in the workshop, so this little motor here, which is 3-phase, is going to be rather awkward to run. Now, if you're in a 240 volt country, you can basically do the equivalent of a rotary phase converter using a single capacitor. It's a bit janky, but it works. Yes, so basically what we do is we're going to connect live from my single phase supply to phase 1 on the motor. We connect neutral from my single phase supply onto phase 2 of the motor, and then between phase 2 and phase 3 we're going to stick a capacitor. And that's the basic setup for creating a phantom phase when you're making a rotary phase converter. So here we are. Let's put the lids down. That looks a bit better, and we work. That's nice, isn't it? Now what's this going to do? Well, let's unplug that so we can have some light. What we have here is the spindle of the lathe, and in the spindle of the lathe is going a device, which I will find. There we go. There is my device. Now, can we see the end of that device? We cannot see the end of that device. In the end of this device, this is basically a boring bar that sits in the spindle. We're going to focus on there. Thank you very much. So, this is a boring bar made for the spindle. Needs an M8 pull nut on it, and inside there is what is known as a micro bore insert, micro bore cartridge. It's a little brazed carbide cartridge with a 0.5mm thread on it, 0.5mm pitch thread, which connects to this nut here. This nut here pulls the insert in or pushes it out, and on the back there's a little screw that holds things in place. There are 40 increments on here. Those 40 increments represent 1/40th of a millimetre on diameter each. So we can dial in a cut of 12.5 micron cut, basically, per increment. And 12.5 microns gives you 25 microns on the diameter for every increment on here. And what we're going to do is we're going to put in, let's move you back here, we're going to put the tailstock here with its clamp in place to hold it in place, but just enough so that it can slide. And we're going to bore it using this boring bar and using the cross slide to push it.